By the end of this lesson, you should be able to define specific heat capacity, C. State that C equals to Q over m theta. A pail of water from a swimming pool has been left for several hours beside the pool. At noon, a lifeguard puts one hand in the water of the swimming pool and then into the pail. The water in the pail is hotter than the water in the pool. Why? We know that both the water in the pool and the water in the pail received the same amount of heat for the same number of hours, yet the temperature of water in the pail is higher than the temperature of water in the pool. Why? Which has more water, the pail or the swimming pool? Obviously, the volume of water in the swimming pool is more than that of the pail. For the water in the pool to reach the same temperature as the water in the pail, it needs to be exposed to the sunlight for a longer time. In other words, a body with a bigger mass requires more heat to raise its temperature by 1 degree Celsius. The amount of heat needed to produce a 1 degree Celsius rise in temperature of the body is known as heat capacity. Heat capacity of the body is defined as the amount of heat required by the body to increase its temperature by 1 degree Celsius. The SI unit of heat capacity is joule per degree Celsius or joule per Kelvin. Which has the larger heat capacity? The water in the swimming pool has a larger heat capacity than the water in the two different masses of water, that is, 200 grams and 600 grams, are heated by the same amount of heat for 10 minutes. Observe the rise in temperature of water in the two containers. Is the rise in temperature the same for both? The rise in temperature of water with a mass of 200 grams is more than that with a mass of 600 grams. What causes the difference in the rise of temperature? The different mass of water. Water of bigger mass has bigger heat capacity. It needs more heat to produce a 1 degree Celsius rise in temperature. Different masses of the same substance have different heat capacities. That is, the heat capacity of a substance depends on its mass. The amount of heat required to raise the temperature of 1 kilogram of the substance by 1 degree Celsius is defined as the specific heat capacity of the substance. Q equals to mc theta, where Q is the quantity of heat absorbed by the substance, m is mass of the substance, C is specific heat capacity of the substance, and theta is rise in temperature of the substance. Specific heat capacity equals to quantity of heat absorbed over mass of substance times rise in temperature, or C equals to Q over m theta. The SI unit of specific heat capacity is joule per kilogram per degree Celsius, or joule per kilogram. An equal mass of water and cooking oil are heated by the same amount of heat for 10 minutes. Observe the rise in temperature of the water and oil. Is the rise in temperature the same for both? The rise in temperature of oil is more than that of water. The two liquids are of equal mass and they absorb equal amounts of heat. What causes the difference in the rise of temperature? Water and oil have different heat capacities. This shows that different substances have different heat capacities. The same mass of water requires more heat than oil to raise the temperature through 1 degree Celsius. Hence, water has greater specific heat capacity, 4,200 joule per kilogram per degree Celsius, than oil, 2,000 joule per kilogram per degree Celsius. This shows that different substances have different specific heat capacities. The table shows the list of the specific heat capacities of some common substances. A 500 watts heater is totally immersed in a block of metal of mass 10 kilograms at temperature 30 degrees Celsius. In 5 minutes, the temperature of the metal rises to 80 degrees Celsius. Calculate the specific heat capacity of the metal. Block is 10 kilograms. Initial temperature is 30 degrees Celsius. Heating time is 300 seconds. Final temperature is 80 degrees Celsius. Power of the heater is 500 watts. The specific heat capacity of a substance is given by C equals Q over m theta. The heat energy supplied to the block by the heater is 150,000 joules. On substituting the values, the specific heat capacity of the block is 300 joules per kilogram per degree Celsius.
Observe the change in temperature when the same amount of heat is used to heat different masses of water. Select the mass of water and drag it to the beaker. Click on the Start button to heat the water. From the graphs, we can conclude that the increase in the temperature of a body, water, is inversely proportional to the mass of the body, mass of water, when the heat is constant. That is, theta is proportional to 1 over m, or theta equals to Q over C times m, where Q over C is the proportionality constant. Q, heat energy supplied. C, specific heat capacity of the substance. Observe the increase in temperature when the same amount of heat is used to heat different liquids of the same mass. Select the liquid and drag it to the beaker. Click on the Start button to begin. What can you say about the rise in temperature of water and oil? The rise in temperature for oil is more than that of water when heated with the same amount of heat. Water has greater specific heat capacity than oil.